welcome to the digital learning. It is SP Smart School. Last time we discussed different formulas of integration. Those basic formulas are used in solving the problem. If you are conversant with these formulas plus the trigonometric formulas, 90% of the integration is done. Now, I shall take up one by one formula and its application in different problems. For instance, we have this problem, integral root x minus 1 by root x whole square d of x. There is no such direct formula, but if we have a glance over the first formula, x raised to power n d of x equal to x raised to power n plus 1 over n plus 1 plus constant c, and of course, n not equals to minus 1. Well, here in this problem, we shall be making use of this formula. To reach at this stage, we open the square of this integral a square means x plus b square 1 by x minus 2 a b. Well, here at this stage I have applied the simple formula, algebraic formula a minus b whole square. Now, this is, I can separate the terms as integral of x d of x plus integral 1 by x d of x minus 2 to integral of 1 into dx. Well, here the power of x is 1. Many of you are thinking like this, okay, can we write it as x raised to power minus 1? Answer is yes. But can we use this formula? Answer is no, because x raised to power minus 1, which is equal to 1 by x, and its formula is log of x. So, I can use the formula here as x raised to power 1 plus 1 or 1 plus 1 plus this will be log of x minus 2, and integral of 1 into dx is x plus constant c. Now, here x raised to power minus 1 and this formula is valid when n is not equal to minus, so we cannot apply. Then there is a direct formula for 1 by x is, or we have a direct formula x raised to power minus 1 as log of x. Now, regarding 1 into dx, this antiderivative and dx is derivative, they are reverse process of each other. So, this dn integral gets cancelled, we are left with x. Another way of understanding is 1 into dx is x raised to power 0 d of x. This is 1 dx, 1 की जगह पे we can write down x raised to power 0 and apply the same formula, x raised to power 0 plus 1 over 0 plus 1, which is equal to x upon 1. So, you will remember it in future, wherever we shall use that 1 into dx, it means x. Next problem, so you can write it as 1 by 2 x squared plus log of x minus 2x plus c, and this is the final result. Then I take up another problem, which is integral x cube plus 3x plus 4 divided by root x d of x. We want to apply the same formula. Well, this is numerator x cube plus 3x plus 4 is divided by root x, which I can write on separate the terms integral x cube upon root x d of x plus 3 x upon root of x d of x plus 4 upon root of x and d of x. Well, make use of the indices x raised to power 3 minus 1 by 2, that is 5 by 2 d of x plus 3 to x power is 1, 1 minus 1 by 2 is x raised to power 1 by 2 d of x plus 4 integral x raised to power minus 1 by 2 d of x. And now we can apply this formula, the first formula, as x raised to power n plus 1 upon n plus 1 plus 3 x raised to power n, in this case is 1 by 2 plus 1 divided by 1 by 2 n plus 1. Then this is 4 x raised to n, in this case is minus 1 by 2, that is minus 1 by 2 plus 1 upon minus 1 by 2 plus 1 plus constant c. And if you simplify, this comes out to be 2 by 7 x raised to power 7 by 2. This is 6 by 3, that is 2 x raised to power 3 by 2 plus 8 by 2, 4 multiplied by 2 upon 1 x raised to power 1 by 2 plus c. So, you can make it as 8, and this is answer. Coming to next problem, we have integral x cube minus x square plus x minus 1 divided by x minus 1. Now, if you compare this result with the one which we have tackled, here in the denominator we had root x, by which we could divide each of the term in the numerator by root x. Here we have a factor x minus 1. So, to make use of this integral x raised to power n dx first formula, what we do? We divide numerator by x minus 1, or sometimes the problem becomes easy if we factorize the numerator. So, while factorizing, its factors will be x square common x minus 1 plus 1 common into x minus 1 divided by x minus 1 and d of x. So, this is your integral x square plus 1 into x minus 1 divided by x minus 1 and d of x. So, we can cancel out this x minus 1, and then integrate it as integral x square d of x plus 1 into dx, and it is simple to x raised to power 2 plus 1 3 by 3 using this first formula plus x plus constant c. Then we take the next problem as 1 minus x and root x d of x. This is, look here, some children must be thinking of integrating it like this, integral of 1 minus x then integral of root x, which is not permissible. We have again to make use of this formula. See how we develop it. Integral 1 into root x is root x d of x minus x multiplied by this will be x root x d of x. So, this is integral x raised to power 1 by 2 d of x minus integral x raised to power 3 by 2 d of x, or this is x raised to power n plus 1 over n plus 1 minus x raised to power n plus 1 upon n plus 1 plus constant c, and you can simplify as 2 by 3 x raised to power 3 by 2 minus 2 by 5 x raised to power 5.2 plus c. We take up another example. Of course, in the next example we have the integral 2x square minus 3 times sine of x and then plus 5 times root x and d of x. Here at this stage we can use this formula, first formula x raised to power n. Here also we can use, but here we have a direct formula for sine, we cannot use as this formula because it is x here whose derivative is dx, here is sin x. So, this is equal to twice integral of x square d of x minus 3 times integral of sine of x d of x plus 5 to x raised to power 1 by 2, that is root x, or this is twice x raised to power 2 plus 1 3 by 3, this is the integral of x square minus 3, derivative of sin x is minus cos x minus plus 5x raised to power 3 by 2 upon 3 by 2 plus c, and you can simplify it as. Okay. Well, then we have next formula. This is secant of x into secant of x plus tan of x. I may remind, in this case, in this question, we have root x with which we multiplied 1 and x. Likewise, if you multiply secant x with secant x, we have secant square x d of x plus integral of secant x tan of x d of x. So, this is tan of x plus secant of x plus constant c. Next is integral secant square x upon cosec square x d of x. Very interesting problem. Now, here to put in the standard form, we can write this as 1 by cos x, cos square x, or 1 by sin square x, which can be written as sin square x upon cos square x d of x. This is the integral of tan square x d of x. Now, there is no direct formula integration for tan square x, but you can convert it as secant square x minus 1 d of x. Now, integral of secant is tan minus x plus c. Sin cube x cos cube x and d of x. Well, in this case, we can break it cos cube x as integral sin cube x cos square x into cos of x and d of x. Well, if we concentrate on this part, cos x dx is the derivative of sine, or we take up the same problem like this, integral of sin cube x d of cos into cos cube x d of x. In the first case, we wrote cos cube x as cos square x into cos x. Now, in this case, what I will do? I will write it as cos cube x as it is. This is sin square x sin of x d of x. Now, here we observe that sin x dx is the derivative of cos x. So, what we do here in this case, let sin of x equals to t. So, derivative of sin x is cos x d of x equal to dt. So, that means for cos x dx we shall write down dt. For sin cube we shall write down t cube. What about cos square x? Let us convert this into sine. Sin cube x into 1 minus sin square x into cos of x and d of x. Now, further this is t cube because sin x is t, 1 minus t square d of t. Let us open the brackets. So, this is integral of t raised to power 5. Oh no, this is t cube minus t raised to power 5 d of t, and apply the first formula x raised to power n as x raised to power n plus 1 upon n plus 1 plus c. Of course, n not equal to minus 1 using this formula. So, this is t raised to power 3 plus 1 divided by 3 plus 1 minus t raised to power 5 plus 1 upon 5 plus 1 plus constant c. So, this will be 1 by 4 sine raised to power 4x minus 1 by 6 sine raised to power 6x plus c. I have replaced t by sin x. Now, in this case, sin cube x cos cube x, we make the substitution here, let cos x equal to t and minus sin of x d of x equal to dt or sin of x d of x equals to minus dt. So, this is integral cos cube x 1 minus cos square x into sin of x d of x. Replace cos x by t. So, this is t cube 1 minus t square to minus dt. In the same way, you open it, this will be t 5 minus t cube integral of this d of t, and finally, you can write on this 1 by 6, same way in this way, t cos x raised to power 5 plus 1 6 minus 1 by 4 cos of x raised to power 4 plus c. Then next comes integral of sin x divided by sin of x plus a and d of x. Now, look here, here we have x plus a and here we have only x. So, to find the integral of this, we create sin of x plus a minus a. This minus a and plus a will get cancelled, you are again left with sin of x. Now, treat this as a and this as b divided by sin of x plus a and d of x. Apply the formula sin of a minus b. So, this will be equal to sin of the first angle cos of the second angle minus cos of the first angle sin of the second angle whole divided by sin of x plus a and d of x. Now, cos a is constant. If you divide this term by sin of x plus a, so keep cos of a constant outside, integral 1 into d of x, this divided by this, minus this divided by this will be cos of x plus a upon sin of x plus a into sin of a. Integral of this and d of x. So, I can further write one step. This is cos of A 1 into dx, sin A is again constant. So, this is cot of x plus A d of x. So, this is cos A into x 1 into dx minus sin of A cot x log of sin of x, that is x plus A. It is a specific formula for cot x. Otherwise, at this stage we could use the formula as f dash x upon f of x d of x alternatively, which is log of f of x plus c, because derivative of sine is cos. So, it will be log of sin x, or you can convert cos over sine as cot x. This is log of sin x, because formula for integral is cot of x d of x is log of sin of x plus c. So, we have made use of the formulas which we have already discussed in the first case. Next, we take up 3 similar problems which are very important from examination point of view. The problems are integral 1 by 1 plus tan of x d of x. The similar problem is 1 upon 1 minus tan of x d of x. Another problem is integral of 1 by 1 plus cot of x d of x. Well, all these 3 problems are to be dealt similarly. I take up the first as this is 1 plus tan x, change this tan x into sin and cos. Tan x, write it as sin x over cos x. So, this will be cos of x upon cos x plus sin of x. Well, I repeat it that we wrote for tan x as sin x over cos x, took the LCM cos x, we have cos x in the numerator, now cos x plus sin x in the denominator. Well, we need to use this formula where we have derivative of the denominator. So, we have to rearrange the terms in the numerator in such a way that we create this cos x plus sin x in the numerator and its derivative. See how. This step is to be understood thoroughly. This is integral. So, denominator is cos x plus sin x. Now, derivative of the denominator is derivative of sin x is cos x and minus sin x is the derivative of cos x. So, this cos x minus sin x is the derivative of the denominator, but we have to simplify in such a way that this is sin of x with positive sign, it gets cancelled with this, and plus the denominator cos of x plus this. Now, here sin x will get cancelled with this and cos x plus cos x will become 2 cos x but we have only one cos x, so we divide it by 2. I repeat this. See, derivative of the denominator is minus sin x plus cos x, as the derivative of sin x is cos x and derivative of cos x is minus sin x. Then we write the denominator as it is, cos x plus sin x. This term sin x gets cancelled with this. So, you are left with cos x plus cos x, which is 2 cos x, and divided by 2. So, I can write the result as 1 by 2 integral sin of x plus cos of x upon cos of x plus sin of x plus cos of x minus sin of x divided by cos of x plus sin of x. This cos x plus sin x will get cancelled with this. So, you are left with 1 by 2 1 into dx plus this 1 by 2 will come with this also, 1 by 2 integral cos of x minus sin of x upon cos x plus sin of x dfx. Now, apply this formula. We have the denominator as cos x plus sin of x instead of f x, and its derivative is in the numerator. So, this is will be equal to 1 half 1 into dx is x plus 1 by 2 log of the denominator, that is cos of x plus sin of x plus constant c. We have to follow the same steps in the other two problems, this and this, which we will try as an exercise, following the same way. Next, we have integral 1 upon x plus x log of x d of x. Here also we shall try to use this formula f dash x over f of x d of x equal to log of f of x plus c. See how we simplify. This is integral 1 upon x common 1 plus log of x d of x. Now, if we look towards this factor 1 plus log x, derivative of 1 is 0 and derivative of log x is 1 by x. So, I can write the result as integral 1 by x plus log of x d of x. So, using same formula here, so we have log of f x means 1 plus log of x plus constant c. So, this is a solution of this. The next is integral 4x plus 2 under root x square plus x plus 1 d of x. In this case, we have to use the second form of this formula, f dash x upon f x. The other form of this formula is f of x raised to power n and accompanied by its derivative, integral of this. So, this is integral of this f of x raised to power n plus 1 upon n plus 1 plus c. See how? Here derivative of x square is 2x plus derivative of x is 1 and derivative of 1 is 0. So, if you try to find out d upon dx of x square plus x plus 1, it comes out to be 2x plus 1. So, we try to create 2x plus 1. See, the other factor is 4x plus 2. Take out 2 common. If you take out 2 common, so this is 2x plus 1 into x square plus x plus 1 whole raised to power 1 by 2 d of x. For the simplicity of the problem, we can rewrite it as 2 fx stands for x square plus x plus 1 पावर n की जगह पे ये 1 by 2 है और इसका डेरिवेटिव is 2x plus 1 d of x. So, if we apply this formula, this 2 will remain as it is. This is x square plus x plus 1 raised to power n plus 1 divided by n plus 1 plus constant c, and when you simplify, this will be 4 by 3 x square plus x plus 1 raised to power 3 by 2 plus constant c. Well, if you compare this result with this, so here f x stands for x square plus x plus 1, n stands for 1 by 2 and 2x plus 1 stands for f dash x. So, we have this formula. Next we take up 1 upon x minus root x and d of x. So, here we shall make use of d upon dx of root x, that is 1 by 2 x raised to power n minus 1, that is 1 upon 2 root x. So, this under root x, if we take out common from this is 1 upon root x common. So, there will be root x minus 1 d of x. Now, here derivative of d upon dx of root x minus 1 is 1 upon 2 root x. Where derivative of minus 1 is 0. So, I create here integral 1 upon 2 root x, of course multiplied by 2, this 2 and 2 will get cancelled, upon root x minus 1 d of x. And now, we use the formula here f dash x upon f x d of x as log of f of x plus c. So, this is twice log of root x minus 1 plus c. The same problem this can otherwise be tackled by substitution. Otherwise, if you take root x minus 1 as t, its derivative will be this integral 1 upon x log of x whole raised to power m and d of x. Now, in this problem we observe that derivative of log x is 1 by x. Now, one approach is by using the formula. Another approach is you make the substitution. Now, for example, let log x stands for t. Derivative of log x is 1 by x d of x t of t. Now, here we have dx and x here. This stands for integral dt upon t raised to power m. So, I can rewrite it as integral t raised to power minus m and d of t. I use the formula now x raised to power n d of x raised to power n plus 1 over n plus 1 plus c. Of course, n should not be equal to minus 1. So, here this will be t raised to power minus m plus 1 over minus m plus 1 and plus c. And finally, you can write it as 1 upon 1 minus m, replace t by log x whole raised to power 1 minus m plus constant c. Next problem we take up. This is integral of e raised to power 2x minus 1 e raised to power 2x plus 1 d of x. A very popular question. The similar type questions of this type are integral e raised to power x minus 1 e raised to power x plus 1 d of x. The other problem could be e raised to power x by 2 minus 1 e raised to power x by 2 plus 1 d of x. Method of solving these three problems is same. Here we observe the power of e is 2x. So, we dividing numerator and denominator by e raised to power x. But if you take up this problem, in the middle one, here the power of e is x. So, here we shall divide numerator and denominator by e raised to power x by 2, half of x. In this case, half of x by 2 is x by 4, and dividing numerator and denominator by e raised to power x by 4. So, I will give you the solution for this problem. So, this is integral e raised to power 2x upon e raised to power x minus 1 upon e raised to power x. In the denominator we have e raised to power 2x upon e raised to power x over 1 over e raised to power x. Precisely, you can extend this symbol of integration like this and d of x. So, this will be e raised to power x minus e raised to power minus x and e raised to power x plus e raised to power minus x and d of x. We make the substitution here, okay, let e raised to power x in the denominator plus e raised to power minus x equal to t. Derivative of e raised to power x is this, derivative of e raised to power minus x minus e raised to power minus x and d of x. So, this is dt. That means, we observe the derivative of the denominator is this in the numerator. We make the substitution as this and we get the numerator. So, this can be written as dt upon t, which is equal to log of t plus c or log of e raised to power x plus e raised to power minus x plus c. And if you are sharp enough, so we could use the formula here that f dash x upon f x d of x equal to log of f of x plus c. So, derivative of the denominator is in the numerator. So, we could directly write as log of e raised to power x plus e raised to power minus x plus c. Well, I leave these two exercises for you to have practice in this. Next, we take up the problem integral of cos of root x divided by root x and d of x. In the denominator we have root x, 1 by root x I should say, which is the derivative of d upon dx of under root of x. This is 1 by 2 root of x. It gives us an idea that we make the substitution here, let root x to t 1 by 2 root x d of x equal to dt or 1 by root x d of x equal to twice of dt. So, we apply here integral of cos of t dx upon root x is twice of dt. Take 2 outside, integral of cos of t d of t is equal to twice sine of t plus c, or this is twice sine of root x plus c. Well, here I will give you another problem. This is integral tan of x upon sin x cos of x and d of x. They are a very popular problem. So, put it in the standard form, what we do, dividing numerator and denominator by cos square x. So, we have the result here, integral tan x under root divided by cos square x and sin x into cos x divided by cos square x d of x. This cos x gets cancelled with this square. So, this is root tan x. Bring this cos square x in the numerator. So, this will be equal to integral tan of x under the root into secant square x whole divided by tan of x sine over cos and d of x. Now, this root tan x will cancel with this, or if you use the indices rule. So, this will be tan of x whole raised to power minus 1 by 2 and secant square x d of x. He will use the formula this f of x raised to power n and f dash x d of x equal to f of x raised to power n plus 1 upon n plus 1 plus secant square x. So, n stands for minus 1 by 2. So, this will be f x means tan x raised to power minus 1 by 2 plus 1 over minus 1 by 2 plus 1 plus c, and when you simplify, this is 2 tan of x root plus c.